In our last set of videos, we started looking at higher order polynomials, and we saw those were polynomials that have a degree of more than 2. First degree polynomials are lines, second degree polynomials are quadratics, and higher order would be 3, cubic, 4, quartic, etc. And when we looked at those, we saw that we had our polynomials. For instance, let's say we have this polynomial. And if we wanted to factor that, hopefully at this point you can factor this pretty quickly and easily. 2 numbers that multiply to give me -6 and add to give me -1. And we saw that these are the factors. And remember, the word factor means the things I multiply together to get the polynomial. So x minus 3 is a factor, x plus 2 is a factor. When we're going from a polynomial to its when we're going from the factors to the polynomial, we are multiplying. We would literally multiply x minus 3 times x plus 2 to get x squared minus x minus 6. So if we were coming back in the other direction, we're using its inverse operation, which is division. So as we move into polynomials that are to a higher degree, x cubed, x to the 4th, when we're trying to find all of its factors, we are going to be dividing. So the first thing we're going to look at in this unit is how to do polynomial division, how to divide one polynomial by another polynomial. And we're going to use a system called synthetic division. And this is just a quicker, easier way of doing polynomial division using symbolism and then going back and putting in the actual equations. So our lesson for this video is how to actually do division using synthetic division. So let's say that we have a polynomial, 3v to the 4th plus 4v cubed minus 11v plus 1. And that's just a polynomial. It's numbers times variables to powers, added and subtracted. And we're using the variable v here, but it could be x or it could be t or whatever letter we want to use. The process is the same. And we're going to look at how we can divide this polynomial by the polynomial v minus 3. And we're going to see when we do synthetic division that we're always going to be dividing by something of the form x minus k, where x is our variable and k is some number. So we're thinking about, what is my k? What am I subtracting from my variable? And in this case, we are subtracting a positive 3. So we're going to write the 3 out here to the side. And we're going to draw our little box here. This is kind of our division symbol here. I guess I could do it. No, I'm going to go ahead and do it that way. It doesn't really matter how you draw the box. Then I'm going to look at the coefficients of the polynomial in the numerator. And notice I have v to the 4th, v cubed, and then it jumps straight to v to the 1st. And this constant here is technically v to the 0, 1 times v to the 0 power. So notice I went 4, 3, 1, 0. I'm skipping the v squared term. I have to have every single term represented in my synthetic division. So if I don't have a specific term, in this case the v squared term, I have to put a 0 as a placeholder for that spot. So I'm going to bring each of my coefficients, list them, making sure that I include a 0 for any missing terms. Then to do the synthetic division, I'm going to drop the first number straight down. So this 3 just drops straight down. Then I'm going to multiply this 3 times what I dropped here. And I get 9, and I write it right underneath the second number. Then I add those two numbers. And then I just keep doing that all the way across. I multiply the 3 times the 13 and write that number here. And then I add and get that one. I want you to pause the video, multiply 3 times 39, write it in the under the negative 11, add, multiply, and add. And I want you to finish out the last 2 steps here. So pause the video, do that work, and then turn the video back on. Okay, so I multiplied 3 times 39. That's 117, and you can use your calculator for these larger numbers. And then negative 11 plus 117 is 106. And then 3 times 106 is 318. And then 1 plus 318 is 319. So this work that I've done here represents the long division of this polynomial divided by this binomial. But when we do division, when I'm literally doing the division, dividing this by v minus 3, the answer of a division problem is called a quotient. So we're going to see that our quotient here is represented by the numbers down here. And notice that I've put a bar right here, and we're going to see that this number is separate, and we'll see what we do with that in a minute. Notice in my division here, I'm taking v to the 4th power and I'm dividing it by v. V to the 4th divided by v is going to give me v cubed. So I'm going to see that my first term here, down here, is going to be v cubed. And then v squared, v, and then my constant. So these numbers are the coefficients of my quotient. And I can rewrite my quotient, 3v cubed plus 13v squared plus 39v plus 106. But I have this 319 left over when I do the division. And what we call that part that's left over after we do division is called the remainder. So we have a remainder of 319. So this piece is my quotient, my answer from my division, and this piece is my remainder. Leave several empty lines after this division because we're going to come back and look at something in our next video. We're going to come back and look at something about that. So leave 8 or 9, 10 empty rows after that division. Let's do another one. In this one, I'm going to set it up, and I'm going to have you see if you can set up the division box. And our instructions just say divide. We're just dividing one polynomial by another polynomial and saying what our quotient would be. And in this case, we're going to divide by x plus 1. And remember that we're looking at x minus k. So we're thinking, what are we subtracting from x? So I want you to see if you can set up your synthetic division write what you're going to put out here to the left, write your coefficients, and remember to look for any missing terms. Count down, cube, squared, first, constant, and see if you're missing any terms. See if you can fill out. Pause the video and fill out your synthetic division box here. Okay, if I have x minus k, what I have here is x minus -1. So the number that I'm going to put out here to the left is -1. When we had x or v minus 3, we use +3. When we have x or whatever variable plus 1, we're going to use -1. Then I look at my coefficients. The understood coefficient here is 1. The coefficient here is 2. And then I have a missing term. I don't have an x term, so I have to put a 0 in for that one. And then my constant is -12. So if you have that correct now and you understand that, go ahead and pause the video and do the actual synthetic division. Bring the first number down, straight down, multiply and add all the way across, and then check back. And we see that we have 1. Dropping the 1 down, we have a +1. Then -1 times 1 is -1. 2 plus -1 is 1. -1 times 1 is -1. 0 plus -1 is -1. -1 times -1 is +1. And then -12 plus 1 is -11. So you go ahead. If you have the correct answer here, go ahead and write what your quotient is equal to, what you actually get when you do this division. And remember, these 3 numbers give you the coefficients of the quotient, and this number is my remainder. We started with x cubed, so we're going to start back with our x squared, 1 degree less. So go ahead and see if you can write your quotient and your remainder. Pause the video, do that, and then check back. All right, so we have 1x squared plus 1x minus 1 with a remainder of -11. Let's look back at this problem. We're going to rewrite this in a different way. This is just an example to kind of help you understand what I'm going to do next. Let's say I divided 21 by 5. And we see that 5 goes into 21 4 times with a remainder of 1. So this is a true statement. This is writing this as 21 divided by 5 equals 4, remainder 1. I could also write this as 21 divided by 5 equals 4. And then my remainder is 1 left over out of my denominator 5. So this is another way that I can write the exact same information. And then there's yet another way that I can write the information. Writing this as a product, as saying what I divided out, the 5, times my quotient 4, plus my remainder equals 21. So that gives me the exact same information, same true statement, written in yet a different way. So we're going to practice writing my quotients, and I didn't leave myself enough room here underneath this one. I should have done that, but anyway, hopefully you did leave some room. But we're going to come back and we're going to rewrite this statement with a fraction, the way we have here. So we're going to see that if I take 3v to the fourth plus 4v cubed minus 11v plus 1, and I divide by v minus 3, that's going to be equal to my 3v cubed, the quotient is the same, plus 39v plus 106, plus my remainder here, but instead of saying this is a remainder, I'm going to write it with a plus 319 over what I'm dividing by here, v minus 3. So it gives me the same information, it's just writing it in a slightly different format. I want you to come down here and see if you can do the same thing with this solution, this division, and rewrite it x cubed plus 2x squared minus 12 over x plus 1. And I want you to see if you can rewrite it with that fractional part. So rewrite this with a fraction on the end. The quotient will stay the same. We're just reformatting how the remainder is written. Pause the video, do that, and then check back. All right, so we see we have x squared plus x minus 1 plus or minus this 11 over my quotient, or excuse me, my denominator, x plus 1. So that's just another way of writing the exact same information. Let's look at using this format, writing our answer in this format. And we're going to see that this one is going to be what we're dividing out. We're going to have that our polynomial, if I call this p of x, and this is x minus a, or excuse me, x minus k, we're going to see that we're going to write this in this form. P of x equals what we divided out, x minus k, times our quotient, q of x, plus our remainder. So I'm going to show you how to do that with this one, and then I'll have you do the next one. So we have our polynomial p of x, and in this case it's v, p of v, 3v to the fourth plus 4v cubed minus 11v plus 1. That's my p of x, except I use a v because I had a v originally, equals what I'm dividing out here, v minus 3, times my quotient. And I see my quotient is 3v cubed plus 13v squared plus 39v plus 106 plus my remainder, 319. So if I actually multiplied this polynomial times this polynomial, distributed the v to each one, distributed the negative 3 to each one, got that polynomial, and then added 319, it would equal this original polynomial. So I want you to do the same thing down here. I want you to rewrite this polynomial, this true statement, and I want you to, let's call this p of x again. And remember, this is my x minus k. I want you to rewrite this, and this is my q of x, and this is my remainder. I want you to write this in p of x equals x minus k times q of x, my quotient, plus my remainder. I want you to write this statement in this form. Pause the video, try that, and then turn the video back on. Okay, our p of x, our numerator function was x cubed plus 2x squared minus 12. And we saw that that was equal to what we divided out, the x plus 1, times the quotient, x squared plus x minus 1, minus my remainder, negative 11. So it's actually plus negative 11, which is the same thing as minus 11. If I multiplied this times this, combined like terms, subtracted the 11, I would get this polynomial. What we've seen in this video is how to actually set up a synthetic division problem, do the synthetic division, and then write our answer, our quotient, in 3 different formats. What we're going to see in our next video is how we can use the synthetic division to determine whether a number is a 0 of a polynomial, whether a binomial, something like this, is a factor of a polynomial, and how we can find function values